Have you ever stared at the stars and wondered about the nature of time? Does it only flow in one direction, like a relentless, unstoppable river? Or could we perhaps navigate this river? Could we sail upstream, into yesterday, or journey downstream, into tomorrow? These are questions humanity has long pondered. The allure of time travel is powerful. It whispers of second chances, doesn't it? Of witnessing history unfold before our very eyes. Imagine seeing the Great Pyramids being built, or walking with dinosaurs, those truly immense creatures. Perhaps you dream of glimpsing the future, seeing the marvels or perhaps the warnings it holds. This yearning is woven deep into our very being. But is it just a beautiful fantasy? A playground for imaginative storytellers and dreamers? Or does science offer a genuine glimmer of hope? Could the fundamental laws of the universe permit such journeys? The cosmos is a vast and deeply mysterious place. It holds countless secrets we are only just beginning to unlock. Perhaps the secret of time travel is one of them, waiting patiently for us to discover its intricate key. Why does time travel captivate us so profoundly? It speaks to a fundamental human desire, you see, the wish to understand our unique place in the cosmos, to connect with all those who came before us, and to imagine what lies ahead for our species. This isn't just idle curiosity, not at all. It's about our story, the grand human story, a story written across the vast canvas of time. Think of the incredible moments we could witness, the grand dramas of history playing out vividly, the quiet, everyday struggles of ordinary people. Each and every event shaped the world we live in today. To see them firsthand would be truly profound. It would offer us a completely new perspective, a deeper, more resonant understanding of who we are. Imagine the incredible historical insights awaiting us, not just reading about the mighty Roman Empire, but actually walking its ancient cobbled streets, hearing its bustling sounds, smelling its distinct aromas. We could potentially solve ancient mysteries directly, understand long-lost cultures from deep within. History would transform from mere text into vivid experience. A living, breathing museum open for careful exploration. Beyond human history, let us think even bigger. Think about the long, dramatic history of our planet, witnessing the Earth's fiery formation, its violent birth, the slow, tentative rise of the first life in ancient oceans, the awe-inspiring reign of the dinosaurs, majestic and terrifying. These are all crucial chapters in Earth's immense biography. But traveling through the currents of time is not simple. It is a path fraught with considerable peril and confusion. The most famous of these is the grandfather paradox. Imagine, if you will, that you travel back in time. You somehow prevent your grandfather from meeting your grandmother. So your parent, one of them, is consequently never born, and therefore, logically, you are never born either. But if you were never born, who stopped them meeting? This creates a seemingly unbreakable logical impossibility, a confusing loop that cannot be easily resolved. If you cease to exist, you cannot perform any action. Some theories suggest the universe inherently forbids such changes. Perhaps you would find yourself destined to fail no matter what, or maybe a completely new timeline would branch off. One where you were indeed never born, a separate reality. Section 5, Einstein's Universe, where time can bend and stretch. So, is the idea of time travel pure fantasy, or does rigorous science offer any genuine clues? Let us turn our attention to Albert Einstein. His groundbreaking theories of relativity revolutionized physics. They fundamentally changed how we perceive space and time. He showed they are not separate, distinct things, but are intricately woven together, a single unified fabric. He called this remarkable four-dimensional fabric space-time. Einstein's special theory of relativity, published in 1905, revealed something truly astonishing about time itself. Time is not absolute, it's not the same for everyone. It is relative. It actually depends on your motion. The faster you move through the dimension of space, the slower you move through the dimension of time for others. This is a real phenomenon called time dilation. Astronauts experience it, though only by very tiny amounts. Then came his general theory of relativity, in 1915. Section 6. Quantum whispers, tiny particles and tunnels through time. Beyond Einstein's relativity, there is another strange realm. The bizarre and counterintuitive world of quantum mechanics. This branch of physics describes the universe at its tiniest scales, the peculiar behavior of atoms and subatomic particles. Here, reality itself is fuzzy, governed by probabilities. Particles can exist in many places or states at once. Until we make a measurement, that is, collapsing possibilities, it's a world profoundly unlike our everyday macroscopic experience. Some quantum ideas touch upon the nature of time. Consider quantum entanglement, for instance, a curious link. Two particles can become linked, no matter the distance separating them. Measure a property of one, and you instantly know the others. Section 7. The weight of choice, ethics and identity in time's flow. If time travel were indeed possible, what then? Beyond the complex physics, there are deep, serious questions. Profound ethical dilemmas would surely and swiftly arise. Who would get to travel through the currents of time, and for what specific purpose would it be used? To correct historical mistakes, or perhaps to gain unfair power? The temptation to meddle with past events would be strong, but the unforeseen consequences could be truly unimaginable. Consider the significant impact on human identity itself. If you could go back and change your own past, would you still fundamentally be the same person? Our experiences, our triumphs, our struggles all shape us. Erasing them might inadvertently erase who you have become. And what if you were to meet your past self, or encounter your future self for that matter? The psychological impact of such encounters could be profound. There is also the crucial question of moral responsibility. If you alter history, even in a seemingly slight way, you could affect countless lives and all future generations. Do we, as individuals or as a species, have the right to make such changes? Who would decide what constitutes a better past? One person's ideal utopia might be another's bleak dystopia. The burden of wielding such incredible power is immense. Section 8. Journey's End or Beginning, the Future of Time Travel. So, where do we currently stand today on this matter? Is the advent of time travel just over the horizon? Most scientists remain deeply skeptical about its feasibility, especially concerning travel to the past, for many reasons. The paradoxes we discussed are formidable logical barriers, and the energy requirements seem astronomically, impossibly high. Building a functional time machine is not a simple task. It is far beyond our current technological capabilities by a vast margin. Travel to the distant future, however, is different. That is a different story, at least in pure theory. Einstein's principle of time dilation is a real, proven effect. If we could one day build incredibly fast spaceships, vessels capable of approaching the actual speed of light, very close. A journey of a few years for the intrepid crew could mean that centuries or even millennia pass on Earth. They would effectively arrive in Earth's distant, unknown future, but even this form of future travel is a colossal challenge.